Hey, this is Joe Burnett on the Runner team. I wanted to show you a demo of Step Runner working in production. I wanted to show you the progress that we've made in both the definition of Step Runner, how it works, how pieces are put together to make a workflow, and also the implementation, which we've been working on in parallel. Yeah, so there's four things I wanted to go through today. First of all, I wanted to give you a demo of what it's like to build a workflow with steps. The last demo that I did, or the last walkthrough, was a really low level, like code level demonstration of how GitHub Actions could be integrated. This one, I want to come from the top. I want to show you like what it's actually like to use steps, GitLab Steps, as well as other scripts. And I wanted to, the second thing I wanted to tell you about was what's missing. Like after you see kind of like what it's like to use it, what else do we have to do to make this thing usable in production and get it to the point where customers can actually build something with it? Then I'm going to take a little bit of a deep dive. I'm going to go back over this again at a much deeper level, showing you how the code actually works in each one of these steps that you've seen. I'm going to tell you how it's changed from last time, the technical decisions that we've made, and the things we've removed. And I'm also going to show you exactly like how this integration is done now. It's kind of, you'll see, it's if you want to go into the deep dive, you'll have questions. If you don't, if you just want to see how it works, you could probably stop after that. So, okay, here we go. I have a little toy project here called Hello Steppy. And it has just one step. Now, let me show you what I've done here. This is actually going to run in production, but I haven't made any changes to production. I haven't changed Runner. I've only created Step Runner as a separate project, built it into an image, and pushed it to this repository. So I'm actually going to do this. I'm going to run this inside of Step Runner image. And these are the steps that I'm going to give it. Now, there's no CI language yet for steps. So as a sort of to get around that, I didn't want to say sidestep, or maybe I do. I just shove it into an environment variable. Just a quick little hack. This was Camille's idea to sort of get it to the point where we can actually run something. And you put the steps here. Okay, I told it not to expand it because I actually want to like have some expansion that I control. This little bit here, just don't worry about this. This is what you need to run Docker and Docker. And that's just gonna come into play later when we talk about containerization. This is where we actually run Step Runner. And there's three commands. Step Runner has a CI command, which knows to look for these environment variables. It has a local command, which is actually pretty cool, and I'll show you later. And then it has a replay command, which I'll tell you about also. And of course, output this, CI outputs this trace JSON, which we capture as an artifact. All right, but let's just get down to business here. When I pushed this most recently, it ran, and what it did was say, hello world. And that's where we're going to pick up. Okay, so I've got this workflow. I really want to build it. Now I've got the code checked out here, and you can see that my step, I use this step called greeting. Okay, it says hello Steppy. And it creates a greeting, gives it a name, and it outputs the name, the greeting, hello world, right? So let's add a little something to it. So you can see what it looks like when I actually like use a step. This is another repository, okay? This is not in my hello Steppy repository. This is another component that I'm using. I should probably name it a little bit different, but it's like a hello world component. And I'm parameterizing it with inputs. I'll show you later what that actually looks like, how these components are built in the deep dive section. All right, well, let's grab something a little bit more here. Here I would like to show you how you can actually get environment variables. So in addition, this step, in addition to giving you a greeting, it returns an output greeting, which is part of the context here that you can use. It also exports an environment variable, which is user. And I'm going to override that. And I'm going to say, actually, I want user to be Steppy. And what I'm doing here is I'm actually saying, run this in bash. And I want you to run this script. We're going to provide some syntactic sugar where you can just say script, and it'll automatically detect what shell to use. But it'll just expand to this. And it says, run in bash this script, echo this to this environment variable. Every single one of these steps gets its own output file and its own environment file. And it can write to that file, this equals that to do an output. And it can say this equals that to export variables, which will be available to the rest of subsequent steps to mutate sort of the whole job context. All right, so theoretically, we've changed the environment variable. And now let's do this again. We're going to run our greeting again here. And this time we're going to, the name we're going to pull from user. So we're going to be like, okay. The user that we wrote here, we should be Steppy now, not world. And we're going to grab that output, just to show how you can take the output from one step and use it in another. The message, we're going to use the output of that create greeting step, the greeting output, as part of the message. All right, so this is what we have so far. So I'm gonna push this. Change name and greet again. And I'm going to push it. That's great. And I'm going to look at these logs. Now, I got to warn you, this is going to take a little bit of time because it has to pull down the whole Step Runner image since it's not built into our CI system. That part's going to go away, right? Like eventually, we'll have that image either available or it'll just be in the environment itself that's executed. This is just my workaround for allowing you to play around with steps in production. While this thing is going, I kind of want to show you, I want to do a little preview of what these components look like. So I'm going to pull up another file here. I'm going to go to this component hello Steppy file, and I'm going to pull up in this step YAML. So here, we define inputs. This is the definition. This is the definition of the step, right? Like actions have action.yaml, steps have step.yaml. In GitLab CI catalog, components have component YAML. You put, who do you want to greet? What's the message? You already saw me use those. And you can see I explicitly said I'm outputting greeting. So inputs and outputs are explicit, right? You don't get anything without asking for it. Same thing with environment variables. The only environment variables that you get without asking are the ones that are exported from other steps. Because, for example, I'm going to export, name. It automatically gets picked up and continue on. This is really important to make these functional. The only exception is going to be bash, because like our first version of the bash shell and all the shells are going to have all the same environment variables CI has always had, just so you can take the scripts that you have now, drop them in there, and they'll still work. But that's sort of an intermediate step. Ultimately, we would like you to declare what your inputs are. Makes it easier to control side effects and to keep things from breaking. This one happens to use Go. So Go actually is available in the Step Runner image because I built it in Go, has Go there. I just easily made this, a Go step, and it just basically does the thing. Yeah, just stick the two together, name plus greeting. That's not really too particularly interesting. It's just to show you how the inputs and outputs work. And look, so here, our job succeeded. We got hello world, just like last time. we ran this step. It didn't have any output. It didn't say anything. Just remember, it just said change the name. And now here was the greeting that we grabbed from before, and there's the new name. So the greeting was, the greeting from before says the user. So it worked. Like this did exactly what we would expect. Now I want to show you what the trace looks like. So here's my job, hello world, that just ran. You already saw these logs, but there is this trace JSON file. And I'm going to save that previous path. Let's take a look at it. Oh boy, that's ugly. I'll show you a better version later. It is basically each one of those steps, all the inputs, all the outputs, the environment variables that went in, the exports that went out. It captures the step definition, like not the file, but the pointer, the reference. And it also captures the hash specifically. Like even when you say at version 1, it grabs the hash so you know precisely which version of that component or that step was used. And it just puts it all out there. And it gives you also the trace also includes the log, the thing that we actually print, the exit code, etc. And what this allows you to do is you get sort of like a complete breakdown of what happens. So you could just take all the logs and just smash them together, and then you have the output, right? That's the easiest thing to do. But you could also make it fold, and you can like expand each step. It also has a hierarchy, so you can show sub-steps when you have one, like when you enter your steps, your actions as a composite or a sequence, you can actually see what happened in each one of those sub-steps and so forth recursively. So, and then all that bubbles back up again. It also includes, since it includes everything about how that was run, it also allows you to take this trace, download it, and run it again locally. So that's the Step Runner replay command that I was talking about. I'm not going to show it to you today. It was working yesterday, but I broke it before this demo, so I'm not going to try to show it to you. But basically all it does is just extracts those steps, skips a piece of the compilation step, which has already happened, to take the YAML and turn it into a proto, and then just runs it again. And that's actually pretty cool because it allows you to you can manipulate the trace a little bit, say, what if I used this image, or what if I gave it this input instead, and just kind of play around with it locally, which is really helpful. And the traces here you can download, which is quite helpful. We're probably going to hide also the sensitive stuff. Each one of these inputs and outputs has a masked Boolean with it. And so by default, this trace is going to have all the secrets hidden. But it would be nice if you could, have permission to download it. Like if you were an owner and you had permission to see the secrets, you could download it, from a special endpoint or something. I don't know. Anyway, so the point is the trace contains everything about what happened. Okay. So that's the deal, but this actually takes a little while to run. So I'm going to stop doing this in production. I'll come back to production, but right now I want to do this locally. And it also gives me a chance to show you what Step Runner local looks like. So I'm going to run Step Runner here on my machine. I pointed it to hello world and to my CI YAML, and told it to output the trace file. And it just runs a lot faster because I've already got all these images pulled. It just hits the cache. So same deal. Here's the trace, a much nicer looking one. You can see name, message, etc. We'll look at the trace again here in a little bit. But let's add to this. Okay, so we've got inputs, outputs, environment variables. Let's do something unusual. Okay, I am going to write a step in Lua. I'll bet you didn't see that coming. Weird, huh? What does that even mean? So first of all, let's say I have something I want to run that does something, happens to be in Lua. Or let's say that I just, have a little snippet that I want to run and I want to extend the workflow without having to extend runner. I don't want to have to change runner to be able to run things in another language. I don't want to have to change runner's production environment, right? Because these are hosted. So I want to run Lua, right? Okay, so what I've done here is I've actually grabbed, I'm actually running a different step, which I called runtime Lua, okay? And I gave it a script. It looks just like this. It's just like another thing, just like another shell scripting language. So actually, I'll even show you what this looks like. Runtime Lua, it just runs Lua. Could do something more complicated if you want. And there's more complicated ones in this workflow I'll show you. But let's run it again. So let's see if that works. But I don't actually have Lua. I want to run something in Lua, but I don't want to download it and install it on my machine, right? Like, I don't know. I don't even know how to do that. So what I've done here with runtime Lua is I actually built a Docker file with the environment that this step should run in. So here I include another reference called image. And I'm saying, okay, go to image, go to the registry, and I want you to take this step and run it, but I want you to run it in this container. So sorry, take the step, bind it in as a volume, run it inside this container, which has the right environment for this step. So let me run this again and let's see if that helps. Oh, I think I forgot to save the file. Okay, now I saved it. Let's do it again. This is why it's nice to do it locally. You always want to have local debugging, right? So there's a couple extra steps here. You notice that it fetched the component. Now you'll see it's also fetching it into these temporary folders. Like each component gets put in here. It goes through a cache too. So if the same component is being used, it will reuse the downloaded directory. It won't download it multiple times. I broke it. You can see it's actually downloading this one twice, but it should be a simple fix. And I need some tests, I think. So here we downloaded Lua, but then we downloaded this other thing called Docker Run. So image is syntactic sugar, right? Like you can actually build all this stuff like with the basic components. What image does is when Step Runner sees image, it says, all right, you want me to put this in a container. And it has a reference to this other step called Docker Run. And so it compiles it into another step and takes the Lua step, compiles it into a command to give to the Docker Run. So Docker Run is just yet another step. And it gets the same input environment, all the same inputs and outputs that anything else does. And I'll show you what that looks like. It looks like this. You get your inputs and your outputs. You sort of put things together. You give it you can get a step path, right? Because remember, you want to take the actual step, bind it into Docker. So here we actually bind it in as a volume, use it as the working directory, etc., and then run Docker Run. Now, the cool thing about this is, since this is in a way external, we can actually parameterize Step Runner with different ways of running containers. Like we can make this just we can make it a flag. You could be like, well, when I tell you to run it in a container, or maybe we should call it like, isolated or something. When I tell you to run one step inside of another, mechanism, use virtual machine or use, other, container technology. Like it's pretty generic. Like, all the details about how to actually run Docker are in the Docker Run component or in the Docker Run step. So yeah, it's quite composable. So anyway, I showed you that. That was pretty cool. We can use Lua now or whatever. Let's do something else kind of weird. All right, now, oops. Now I have this step, terrible password. All right, I wrote a step. Actually, I wrote an action which produces a terrible password. This is what happens when I don't actually have anything to do. I just make stuff up. And here I've given an action keyword. This is not like for sure how it's going to look, but what this does is it goes and gets a GitHub action from an action.yaml file, reads it, translates it into a step because it's a pretty straightforward translation, and then just runs it like any other step. And here what I've done is I just went ahead and slapped it inside Node because my machine isn't set up to like run actions. I do have Node, but I don't think it's even the right version. So this is a little preview of what like running actions might look like. And really, you shouldn't have to even say this because when you look at the action, it tells you what version of Node. So when we do this compilation, when we translate it, we'll just slap the appropriate image on it. So if the action says using Node 20, using Node 18, etc., we'll just say, okay, run it in this image or that image. And then it'll have, that action will have the correct environment around it to run. Yeah, let's see if this works. All right, and I'm still doing it local. Still just using the same pieces over and over again. Docker running, components like the input output files. This one, this translation allows you to actually scrape the output, the log for the special output from GitHub Actions. It's built in. And yeah, it actually ran this terrible password from GitHub. And it did the same deal. It wrapped it up inside of the Docker run step. And it ran. There it is. And let's see what the output was. Let's see if we can actually get outputs from these actions. Okay, so here I just slapped on another script and I grabbed output of terrible password and I grabbed password. So let me show you real quick what this looks like. Here's my action YAML. This is the GitHub definition, just here's my password. Here's what to run it in. It even says, like run it with index.js, whatever I put here gets wrapped up in that translation layer and given to the Docker run command because it knows how to do it. Okay, so I'm going to have it go run. Oops, sorry. Local. Run the Step Runner thingy again, my whole workflow. And yeah, there it is. We got the password. Now I want to show you the trace again, because I want to kind of show you how all these pieces actually look. So I'm going to pull up the trace and we're going to come all the way to the end. So here, oops, you can see that a GitHub action, looks kind of just like anything else. We've captured the exact hash that we ran. This is protocol 1. I mean, I wish that it serialized as a string, but in protobuf, that just means Git. There's other protocols supported. You can, for example, give a local path. So if I said location ... slash, path to terrible password, like I could actually delete all of this and just put ... and it would run from my local file system. This is what I used when I was debugging it. Like when I was running this over and over again, as a matter of fact, I could even show you what this looks like. You just put ... here and remove the @ because, a path doesn't have a tag. and it will run it from your local file system. There's another protocol supported, which is zip. I haven't implemented it yet, but what it does is it'll just grab a single zip file, unzip it, and then it's just like a git pulled something, right? You have this directory full of files. One of them will be step YAML. It'll read it, continue as normal. Yeah, so that's what a step looks like. We stripped out the output line, like from the log, so it just, you don't actually see the outputs because that's kind of bad practice. GitHub is actually, I think, moving away from these log-based outputs and going to the file-based ones. That's kind of that's the way that's going to go. And yeah, that's it. Okay, so I just showed you a pretty complicated workflow for a prototype like this that put a lot of different pieces together. Actually, one last thing I should really do. Does it run in production? So this is what I'm going to do. I'm going to push that. Okay. And we're going to watch this in the background. Takes a long time. And meanwhile, I'm going to go on to the second part of this video. I want to tell you about what's missing. Like I showed you a bunch of stuff that Did I push that? And I got to push it. Okay, great. Now a job should be running. Okay, so I showed you a bunch of stuff that works, right? But there's a bunch of pieces that are missing. And I wanted to kind of enumerate those so you can have an expectation about like what works, how far we are from something useful. One thing that is missing is tests and test frameworks. So I've been using this to like experiment while we're working on the blueprint. With an eye towards actually using it. So like it's all there, it works, it's reasonable, but it needs a lot of tests to make sure that I don't break something like I just broke replay. The only test that I've actually been using is kind of a cool one, but it's not really sufficient. This test just runs CI YAML and makes sure that the trace is exactly what we expect, which actually does quite a bit, because like it means exactly what you did was exactly what we expected. But like we still need unit tests so you can edit the structure of this thing. And then it takes that trace and it replays it and asserts that the resulting trace from that replay is the same as the initial trace, because if you take those steps and rerun them, if it's a deterministic workflow, it should produce exactly the same output. And I've been careful to make sure that that's the case. So this actually kind of kept me from stepping on my own toes quite a bit while I was working on it. But anyway, so we need tests. Let me pause for a second and just kind of point out that this thing actually passed. So I made all these changes locally, right? And I was able to also push them and they worked exactly the same way. So like if you actually look at those two commands, the CI command and the local command, they're really just shims to get the same structure, to get those steps. As soon as you have steps, then it goes into the same code path. So what works locally should work in CI and vice versa. Very important. That brings me to another thing that's kind of missing, workflow expansion. So when I ran this locally, you'll notice that I gave it, job name, hello world. That really only works for like really, really simple workflow files. And that's not what most people have. Like if I give you this, it knows to look for this, in a hello world step, it knows to look for this like these inline steps. And of course, we'll update this so that like once the syntax is there, I can pull them out. But steps like these, the whole manifest workflow can come from a variety of different things, from templates, from imports, from like variable expansion. Even the steps themselves may be like sort of like compiled. And from what I've been told, this is actually a pretty complicated and integrated part of GitLab. It's not easy to pull out because a lot of that stuff comes from the database, right? Like the variables that are hidden. So we need a way to point at this and expand it into that complete workflow that runner gets. So the runner and thereby step runner can get a whole like correct job, like all the steps, and then it'll take it from there. So there's a missing piece here. And what I'm hoping to do is to enhance or create an endpoint where you give it the GitLab, CI/YAML file, and it returns to you the expanded, compiled, like large version. And then you can grab the job that you want in the same way, and it'll all be there. We need a way to like add files and to incrementally like change it. But it's really powerful once you can get it working, because you can see how easy it was to work on this locally, as long as I can get that proper job definition. So if we can unlock like that workflow expansion, then you can get a really nice workflow and address one of the biggest pain points of runner, which is GitLab workflows, which is running them locally, debugging them, developing them like their code, right? Like any other code, you want to be able to really get in there and sort of like have a nice tight loop. So what else is missing? I showed you running an action, but it's a pretty trivial one. There's a whole bunch of like action compatibility layer stuff to do, and I think we're not planning on working on that until like Q1. So don't expect a lot actions to work unless they're trivial. So this was just to sort of show how the pieces fit together. Other things that are missing, all this stuff was done sort of like as exploratory code and then experimenting and later on moving toward MVC. So this all needs to now, along with tests, need to get put into like the canonical repo. Each one of these components, like the bash one, the running Docker, those steps need to get put into the place that we want them to live. And we need to think carefully about that, because these references are going to be built into people's code, into their steps. And we need to build out some steps to replace all the built-in ones. So like pulling the source code, uploading the cache and the artifacts and all that should be done, each one with a step. And then when runner should not do those extra things. Like it should, you should get the whole everything to do as a set of steps, and step runner should do it all. Runner should be doing less and less. And it is. I think what this does is this replaces the whole abstract shell, instead of like compiling all of this stuff, in sort of sticking in various things and compiling it into a shell script. We've got a very first-class data structure. Let's see, what else? Oh, I didn't actually show you what composites and sequences look like explicitly. Like all of these steps that I used were just exec types. There's two types, there's sequence and exec. Exec just does the thing. Sequence is another sequence of steps, but the code is actually there, and we actually exercised it. If you actually look here, see this bit right here where it says types and steps? This is exactly the same as what you would put here under content. And also this is going to change. We're going to follow the component catalogs, like to-document schema, and collapse this. But so this is a type exec. This is a type steps. So all this stuff that I typed here, you could grab all that, stick it into a step YAML, give it some inputs and outputs, and it could be a step. You could just reference one step that does all these things. So it's very recursively composable, which is a very important part of this. This was Camille's inspiration. He kept pushing to like make it simpler and simpler. And I think I really like what we ended up with, that it's just, this is just actually kind of the implementation of another step. Eventually, there might be other types like parallel. If you want to do a bunch of things in parallel, you could have like a parallel step. For example, one legitimate, solid use case that Camille was mentioning was if you have a couple of steps that have huge dependency trees, like maybe you have a Maven repository to pull and a bunch of Node.js dependencies, you could do those, you could sort of do those two in parallel, since it's network bound, get all that done a lot faster, and then speed the whole workflow up. So there are reasons to run things in parallel. Other things we might actually want to have like gRPC in a more like controlled binary protocol for running things instead of just an exec. If we want to, for example, get line by line each output, line, like if we want to show the exact streaming outputs. Right now, you get each step sort of like, okay, run these steps, and you get step output 1, step output 2, step output 3, and those get printed one at a time. But if you want to see something at a smaller granular level, we can exert more control over it. But all that shims in quite nicely. It's not too much more. You don't have to change very much about this. Yeah. I think that's just about it. I know I just listed like a ton of things that are missing, but it's like working, right? And I think as soon as we get it into the repo, get some tests in place, maybe fix a few rough edges, I think it'll be actually something that you can play with. And again, what I have here is just running in production. Like it really is like nothing special. It ran on, it ran on one of the green or blue runners. Let's take a look. Let me prove it to you. Come on. Oh, I got hit enter one more time. Okay, what did we get? Yeah, see it. Did I say it? Pairing environment. Oh, yeah. Okay. All the way up here. Green 1, SAS, Linux, small. See? It's just the usual. Okay. So that's steps at eye level. That's like what it's like to use steps, what it's like to like how they fit together, how you fit actions in there and scripts. I do want to do a deep dive and show you exactly how all that code works. But actually, this video is getting kind of long already. So I'm going to cut there, and I'll upload another video where I go through each one of these steps, because I want to show that, like, I want to show our developers and contributors how this actually works, like what the code looks like how do we cache it, how do we bring the environment together, how do we mutate the environment, all the details. But I'll save that for another video. For now, there it is. It's a preview of the functionality that's there. I'll link in this description of this video there's 2 blueprint merge requests that are sort of related to this. One is implementation details, and that goes over like the proto structure that I was describing and the trace. And the other is from Camille, which is the steps language. And since everything kind of recursively keeps coming back to the steps language, even like for example, when I put something inside Docker, I created a new step and then compiled that. That's a very important and core piece of this too. And so Camille's written out exactly what should be in there. It differs slightly from what I've showed you. The code that I've showed you is going to match that spec. And Camille has a reference and working Golang compiler for that spec too. So yeah, eventually it'll look like that. So if you want to kind of follow along with this, implementation merge request, the steps definition merge request into two different subdocuments. I'll link that in the description. Yeah, and go try it. Like, go check out this hello here, git remote, show origin. Go check out the hello steppy thing. You can copy that and try a couple different scripts. Tell me what you think. See if you can do something weird with it. And don't be surprised if there's bugs. Don't use this in production, even though it's running there on our production machines. It's just like a completely separate thing that's work in progress. And of course, once we move it into the canonical repositories, we'll give a whole epic and like explain like when it will be at what levels of maturity. But there it is. Play with it. Thanks for watching my video, and I hope it was cool. I hope it was fun. Bye.